Hi, my name is Suryansh, and I'll be talking about application logic vulnerabilities and my own journey into cybersecurity, along with how I got two CVEs completely by accident back in middle school from Apple. So here's a basic who am I? I'm currently enrolled in high school and I love to do CTFs. To be honest, I think I do it every weekend for almost a year along with bug bounty hunting because I think it's a really rewarding hobby and career. I started off with iOS development back in 8th grade, which paved my way into iOS security with those two CVEs, and I managed to publish two apps to the App Store. And a fun hobby of mine is just poetry and playwriting. If you want to see any of my pieces or any technical articles, feel free to check out my Medium, which I'll link in the last slide. So here's a basic overview of what we're going to cover today. We'll start off with what exactly are application logic vulnerabilities, what are the different types of logic vulns, along with how to exploit them. And I'll start by giving different examples into different instances where there were logic vulns. And then we'll move on to methodologies, and I'll talk about the general conventional methodology a lot of people have while, let's say, approaching a pen test or an HTTP box or a THM box. And then I'll move on to my own accidental CVEs and just give a more practical insight into what I did step by step with screenshots. So here is a general overview as to what exactly are application logic vulnerabilities. So to be basic, they're just weaknesses in app features. You can talk about it like a lack of sanitization. For example, when a site blacklists certain characters or does not blacklist certain characters in an input form or a certain parameter, which allows an attacker to exploit a certain vulnerability, or let's say broken authentication, where an attacker is able to just get the same privileges as the victim, and the authentication is considered broken whenever these attackers are able to compromise sensitive information, for example, like session tokens, which allow for account takeover. And then access control is a pretty basic upfront logic vuln, which basically states that a user can act outside of their own intended permissions, which leads to unauthorized access of extremely sensitive data. Insufficient workflow validation basically is more of a developer side flaw, where developers make flawed assumptions about the sequence of events that a user will go through in a workflow, which could lead to further vulnerabilities like two-factor authentication bypass and even privilege escalation, which I'll be talking about in my CVEs. I'll also talk about denial of service with business logic in the examples below. Okay, so here are some examples of logic vulns. We'll start off with basic parameter manipulation, where you can see in the first example where, let's say, you're checking out your order on a site, and the cost is $1,337. And you notice that it's actually hard coded into the URL. And if you edit it and change it to $1, it immediately changes back to $1. Obviously, this isn't very common nowadays, but it's still is reflected in vulns like, for example, HTML injection. We see the same type of flaw with banking accounts, or basically any profile which has and contains sensitive data. For example, if your account ID is 69420 and I change the URL parameter to 69421, I'm going to be able to look at the sensitive data of the user under 69421, and an attacker can actually change this vulnerability and get an entire credential dump or find out the entire admin credentials by maybe changing the ID to something like 0 or 1 in order to gain administrative access. You can see the same exact idea in cookie manipulation, where you can change the cookie value of, let's say, a user from 28 to 29, save the cookie and reload to see it take place. In this example here, I'm using a Firefox extension, although you could use something like Burp Suite and intercept the request and change the cookies from there. So to go back to what I was talking about in relation to denial of service with business logic, let's say you were perhaps booking movie tickets in, let's say, a time restriction, or perhaps 3 minutes before a timeout without any ticket limit. And you're able to book tickets without actually going through with your order first. And users are able to see that you've actually booked these tickets. So you're able to just book as many tickets as you want, but don't actually purchase those, which qualifies as a DOS attack. And using kind of the same logic, incorrect validation also qualifies as a logic vulnerability, where let's take, for example, a loyalty program hack, where an attacker buys a product, gets points for it, and then immediately cancels the purchase, but still has those points. So now we're going to move on to methodologies. So usually when I used to look at a pen test or bug bounty target, I would look at the in-scope targets first, which are basically the targets that a company explicitly lists out that they'll accept reports for. And instead of actually looking at the targets first, I would immediately start with enumeration and look for open ports, IPs, etc., and then find vulnerable services, try assisted manual exploitation with something like Burp or OWASP, Z attack proxy, and maybe try to find some outdated versions of the service running and search for perhaps an RCE or remote code execution in exploit-DB. But there's something missing. So what exactly is missing? And that's actually interacting with the application itself before starting the entire enumeration process. So what are we looking for? Well, on the basic level, we're just looking for logic vulnerabilities. We're looking for interesting plain text parameters or plain text cookies, which I talked about in parameter exploitation a couple slides ago in relation to Privesk. Or you could talk about, instead of them being plain text, they're under basic encryption, like 0xd4, and you're able to immediately decode those cookies or parameters and still manage to exploit the service. And as previously said before, HTML injection is also a pretty big vulnerability, which hints at possible further vulnerabilities, which you can chain for privilege escalation. And one of the biggest points that I have to make in this presentation is that one of the biggest things that you need to look for are users with different privileges, like an admin, an owner, someone with less privileges, and then you're going to try to find different services which allow you to escalate those. And finally, information disclosure. At the end of the day, information disclosure is probably one of the most important aspects of finding any vulnerability, because you never know how interesting and useful that information will be on the long run. So moving on, I'm going to give a quick overview of my accidental CVEs, which I got back in middle school, I think in 8th grade, from getting kicked out of an iMessage group chat for spamming memes. And I was really bored, and I found a critical privilege escalation vulnerability, which was affected in iOS up to iOS 13.6 and iPadOS 13.6, while I found another one right after, which was also privilege escalation and followed the exact same logic. but was only affected on Apple iOS and iPad OS up to 13.4.1. So to give further insight on how exactly, the first one was through Game Pigeon. So if you're wondering what Game Pigeon is, it's a mobile gaming app for iOS devices, which was launched, I think, in late 2016 as a result of an iOS 10 update, which allowed users to interact with the Messages app. So basically, you could send an invite for a user in your DMs or in a conversation to play a game with you, which I thought was pretty fun. And I used to do that with my friends all the time. So this CVE was, this vulnerability was pretty simple. It was only 2 steps. The user would just enter a past Crazy 8 game that they sent out from a conversation that they were kicked out of previously. And then the second they join, they just press the resend button on Crazy 8 and the user is automatically allowed back into the conversation without an invite in the first place. So how was I able to do it? So here are some screenshots from the POC. As you can see here, I sent an invite to some of my friends on an iMessage conversation to play Crazy 8, and then I told them to kick me out. Right after, I noticed that you can still enter the Crazy 8 game, and if you go and press the right-hand corner, I noticed that the resend button was still available, and I wondered if I'm still able to interact with the game even if I'm kicked out. So I pressed resend, and it actually sent. I wasn't expecting anything, but the second I exited out of the Crazy 8 game, I realized I had access back into the conversation. So this was pretty mind-blowing. I didn't know what to say, and I tried it out on different devices. I thought this was just mine, but I realized this is an actual flaw. So after messing around with some of my friends for a bit, I decided to report it to Apple, and I got a CVE for it. So from there on out, I got really interested in the same vulnerability, because if that happened in Game Pigeon, who knows where else it could happen. And matter of fact, I was right, because there is a feature in iMessage called Digital Touch, and the same exact flaw was present there too, except with an additional step. So basically, in an iMessage group, the attacker, who we can refer to as user 1, would send a digital touch message, similar to how you sent an invite to the users to play Crazy 8. And then the receiving users, who we'll use as a collective term as user 2, would then remove user 1 from the group. And then user 1 would actually go back into the previously sent digital touch message and edit it. So similar to how we were able to go back to the Crazy 8 game and mess around with it, we're able to do the same exact thing with digital touch. So after editing and sending the message, you're able to gain back access into the conversation. So to provide more insight into that, here are some screenshots. I asked one of my friends to kick me out of the conversation right after I sent a digital touch message. And if you didn't know, once you get kicked out of the conversation, you can't review the message history right after, but you're able to view message history before. And I was able to go back into the digital touch message and edit it. So I was able to edit the message. And if you look at the bottom right-hand corner, I was able to send it. And the second you send it, you get access back into the conversation. So, oh wow, this ended a bit early, but a basic review of this this vulnerability, it's that logic vulnerabilities are pretty underrated while you're working in, let's say, a bug bounty program, where most people just jump into automated scanners or start manual assisted exploitation or work with Metasploit, etc. But the core thing is to just work and interact with the application first. Realize how it works, look at the different features, and just learn from the application before you start exploitation. So here are my contacts. If you want to contact me on Discord, here's my ID. I'll respond pretty fast. Here's my email. If you want to view any of my poetry or technical articles, this is my Medium, and that's my Twitter. Thank you.
Awesome. Let me just check. I think we've had a few questions. So you covered a lot of content. Give me a second. Do we actually have any questions for you?
Let me take a look.
I mean, I have a question for you, so I'm just gonna inject myself into this conversation more than I already do. Yeah, you basically obtained 2 CVs by getting, accidentally kicked out of iMessage rooms. Have you tried replicating this? So you've tried replicating this with another app at work, right? But have you tried once you disclosed it, they fixed it. Have you tried doing similar things to see if maybe a variation of that bug wasn't patched or something like that?
Yeah, I've tried that multiple times, but according to the staff at Apple, Apple Security, they said that they fixed the issue, and they said it was an issue with tapbacks, which basically allowed the user back into the conversation. So even previously before, when I was looking at the next CVE, which I found for digital touch, I decided that if I found this, there must be something else. So I was looking through all of them, but I think it only affected Game Pigeon and digital touch.
Awesome. Okay. I mean, everyone is very, very, very happy. Also, congrats on the accidental CVEs for everyone also. Like, usually you go into this trying to find a CVE, you just don't click on the wrong thing and get a CVE.
I mean, like, when I started off, I had no idea what a CVE was. And to be honest, I was expecting a bug bounty, of thousands of dollars. So when I got a CVE, I got pissed off. But then after I did some CTFs, I got more into the infosec industry. I realized that CVEs are a pretty big thing, and I should be proud of that.
Yeah, that is so awesome to hear. That's really impressive. I'd also like to thank you for coming out and speaking for us today. I'd like to thank all of our speakers who took the time to sort of, present what they have prepared, their knowledge, everything. It's so wonderful to get to hear all of this, and a really big thank you to you too.